Welcome to this deep dive. Today, we're talking about a genuine technical revolution, the CSS Anchor Positioning API. Until very recently, building tooltips, drop-down menus, and other floating UI elements often meant reaching for JavaScript just to calculate exact coordinates and track scrolling or window resizing. But CSS has been moving fast, and now it offers us a new native solution. No libraries, no JS, just pure CSS. Here's a quick look at what we'll cover in this video. First, core concepts and the basics. Second, positioning targets. Third, the anchor function. Fourth, smart adaptability, fallback values. Fifth, advanced techniques, multiple anchors. And the last one, real-world examples. Let's walk through the core concepts and the whole point of this tool. At the heart of the API is a relationship between two elements, the anchor and the positioned element, the target, where anchor, an element used as a reference point for positioning other elements. That's exactly where the name comes from. Say you've got a profile photo or a cart icon on an e-commerce site. That's your fixed point of reference, the anchor. In CSS, we just give that element an anchor name with some unique name, and that name starts with 2 dashes, exactly like a CSS custom property. And the second piece of the puzzle is the target. Target, an absolutely positioned element, placed relative to the anchor using position anchor. Say this is your settings dropdown or the little cart preview pop-up. This element needs some way to find its anchor in the page's code so it can attach itself to it. That's what the position anchor property is for. We pass it the exact name we came up with in the previous step, so the whole trick of linking them together comes down to 3 steps. Name the anchor. Attach the target to that name. Absolutely critical. Give the target position absolute or position fixed. This last one is genuinely make or break, because without it, nothing will work. The target element has to be pulled out of normal document flow, no way around it. Now that we know how to link an anchor to a target, we can get into positioning the target relative to that anchor. 2 properties handle this. Position area decides which side of the anchor the target lands on, and position visibility decides when the target hides if it runs out of room. Position area lets you position an element around its anchor by giving 1 or 2 keywords. Physical keywords. These are intuitive: top, left, bottom, right, center. For example, position area top right places the target above and to the right of the anchor. And logical keywords. A bit more interesting here: block start, block end, inline start, inline end, and center works here too. For example, position area block end inline start places the target below and to the left of the anchor. In languages like English, that's after the anchor on the block axis, before the anchor on the inline axis. You can also drop an axis when using logical keywords. Just write the block axis first, then the inline axis. Position area start end is the same as block start inline end, and it's also the same as inline end block start. One important nuance: logical properties position the element based on the writing mode of its containing block. If you want to base it on the target's own writing mode instead, add the self modifier. For example, self block start instead of block start. If you didn't already know about these logical properties and what they're for, drop a comment below, and I'll definitely make a dedicated video on that. Position visibility. The classic problem: stranded floating elements. We've all seen this. You scroll the page, the anchor scrolls away, and the little menu is left awkwardly hanging somewhere over the site header. Position visibility kills this problem at the root. The moment the anchor scrolls off screen, the popover attached to it gracefully disappears. To hide the target whenever the anchor is hidden, set position visibility anchors visible. And this isn't just about scrolling off screen. It applies to any way the anchor gets hidden, including visibility hidden. The next part is fine-tuning with the anchor function. Sometimes the standard 9-cell grid just isn't enough, and you want full pixel-precise control. That's where anchor function comes in. Anchor function takes an anchor name and a side. If your element already has a default anchor set via position anchor, or implicitly, say through popover, you can drop the anchor name entirely. Fallback values. If anchor function can't find a matching anchor, the whole declaration becomes invalid. This can happen if the anchor comes after the target in the markup, or if there's no element with a matching anchor name. Anchor side keywords. The anchor side value decides exactly which edge of the anchor the target hooks onto. Just like position area, it supports several kinds of syntax. And one more genuinely impressive trick: anchor size function. It sizes the target based on the width or height of its anchor. Anchor size function takes an anchor name, or falls back to the default anchor. By default, it returns the anchor's size on the same axis it's used on. So width. Anchor size function returns the anchor's width. You can also point it at a different axis explicitly using the physical keywords width and height, or the logical block, inline, self-block, self-inline. Here's the example this whole feature exists for. A tooltip that needs to be exactly as wide as the button underneath it, or a search results dropdown that has to perfectly match the width of the search bar, even as the browser window keeps resizing. This is where anchor size function solves the problem in a single line. The results list's width now tracks the search bar's width live. No resize observer, no get bounding client, rect in JS required. What happens when the screen runs out of space? Picture this. You've set up the perfect menu that opens to the right, and then someone opens the site on a narrow phone screen, and the menu slams straight into the edge of the display. Luckily, there's a fallback position mechanism built exactly for this. The position-try-it rule lets you pre-write alternative coordinates, and then the position-try-fallbacks property collects them into a priority list, and that's it. The browser tests through the options on its own. For the most common scenarios, there are ready-made flip keywords that cover most typical cases. Flip block and flip inline try to flip the target across the block and inline axes. You can combine them, flip block flip inline, to flip across both axes at once, and flip start flips the target across the diagonal running from the anchor's start corner to its end corner. You can go further and build your own fully custom fallback with position-try-at rule, setting margins, alignment, and even switching which anchor the target is attached to. Elements can be attached to more than one anchor at once, which means you might need to position a target relative to several reference points simultaneously. To do this, use anchor function and explicitly name which anchor each side refers to, right as the first argument. Here, the target's top left corner is pinned to the first anchor's bottom right corner, while the target's bottom right corner is pinned to the second anchor's top left corner. Picture two handles on a price range slider. With CSS, you can build a connecting bar attached to both handles at once. It'll dynamically resize itself in response to either handle moving. But here's an important nuance. Behind all this powerful visual magic lies one critically important detail. Visual attachment in CSS doesn't create any real semantic relationship at the HTML structure level. Anchor positioning positions an element relative to another one, but it doesn't inherently establish any meaningful relationship between them. If there genuinely is a semantic relationship, say the target is a sidebar comment tied to the anchor's text, use area details, pointing from the anchor to the target. Enough theory. Let's turn this into working components you'll actually use in real projects. Example number 1 is basic tooltip, just one line, position area top center. And we got what used to require an entire config object in a JS library. Example number 2, same tooltip, now with overflow protection. For this, you need to add a fallback, and the tooltip flips itself automatically when the button ends up near the bottom of the screen. Only one line, flip block, and no more of that wrong position to snap to right position flash that shows up in nearly every JS library. Example number 3, a drop-down menu matching the button's width. This is where anchor size function comes in, alongside a popover pairing. Opening, closing, escape, and click outside are all handled by the browser itself, without a single line of JS anchor positioning decides where. Popover decides when. Together, that's the entire feature set of a JS drop-down library, built from 2 native platform pieces. And example number 4, a menu that picks its own direction. If your menu can have anywhere from 3 to 30 items, use position-try-order, so the menu automatically picks whichever side has more free space. Most block size means, of the available options, pick the one with the most vertical space. A long menu near the bottom edge of the screen now opens upward on its own, with 0 if statements in your code. But before you take this into a real project, 3 things worth knowing up front. First, old Safari. Versions before Safari 26. Either don't understand this API at all, or only support basic placement without position-try-it rule. Wrap production code in supports at rule and define a fallback position outside that block. Second, popover hint for hover-triggered tooltips is currently Chrome only for cross-browser support. And the last, if you're rendering the same card 50 times with an identical anchor name, every instance resolves to the last element in the DOM. Anchor scope all on the parent fixes this. Wrapping up this deep dive, one big question naturally comes to mind. are large projects ready to fully replace their JS solutions with native CSS. It's clear we're standing at the threshold of a new era in building web interfaces. But whether CSS can fully push JS out, that's something only time will tell, and it'll be genuinely fascinating to watch.